Hi students, I am your physics lecturer Noor Ahmad. Today I am going to discuss about a topic is waves. What is a wave? Wave means what? Wave is a one kind of disturbance propagate from one place to another place is called a waves. In a waves, longitudinal waves and stationary waves. So already we discussed about a longitudinal waves. Now this class we are going to discuss about stationary waves or standing waves. What is the stationary waves? Stationary waves means two progressive waves have a same frequency and amplitude and velocity also, travels in opposite direction, superimpose, form a loop or segment is called stationary waves. Suppose you take a one long string, one end of the string is attached to a rigid support, another one end of the string is attached certain weight. When your weight increases, tension is formed in a string. When tension is formed in a string, when you pluck that string, here loops are formed or waves are formed. When these waves means this is one of the progressive waves touches to a pulley, again it will reflect. After reflect, again come back to a origin. This is a stationary waves. Formation of stationary waves in a string. So in a stationary waves, you observe this one, antinode and nodes are formed. What is the antinode? What is a node? Antinode. AN is called antinodes. Antinode means the maximum displacement or maximum amplitude of the wave is called antinode. What is antinode? Maximum amplitude. Maximum amplitude of the wave is called antinode. Here the pressure and density is very low. Pressure and density very low. Pressure and density very low. Very low. The distance between two antinodes. The distance between two antinodes. Distance between two antinodes is lambda by 2. Lambda means what? Wavelength. Lambda by 2. Again node. What is a node? Node means the minimum displacement. So when you one string is attached to rigid support, another end is pass through from a pulley means at the end of the rigid support and pulley, here nodes are formed. Node means minimum displacement of the particle or minimum amplitude of the wave is called a node. Here at the node, pressure and density very high. Pressure and density very high. Pressure and density very high. Next one is the distance between a node and antinode is lambda by 4. Distance between node and antinode. Distance between node and antinode is lambda by 4. The distance between a node and antinode is lambda by 4. This one is a stationary waves. What is a stationary waves means? The two progressive waves have a same frequency and amplitude and velocity, travels in opposite direction, superimpose, form a loop or segment is called stationary waves. Suppose you take a long string, one end of string is attached to a rigid support, another end of a string is passed through from a pulley attached at certain way, tension is formed in a string. So when you plug that one, loops are a form. In these loops, so here antinode and nodes are a form. What is the antinode means? The maximum displacement from a mean position is called antinode, and at the antinode the pressure and density is very low. The distance between a two antinodes or the distance between a two nodes is lambda by 2. Why lambda by 2 means the waves travels in L is equal to here 2 times node, so that's why it will come lambda by 2. Again another one is node. What is a node? The minimum displacement or minimum amplitude of the particle is called a node. Again at the node pressure and density is very high. Again the distance between a node and antinode is lambda by 4. This one is a stationary waves. Next one is terms used in a stationary waves. What are the terms used in a stationary waves? One is a fundamental vibrations or a fundamental frequency. Fundamental vibration or a fundamental frequency means the frequency of the wave is minimum. That frequency is called fundamental. What is the fundamental? The frequency of the wave is a minimum. If the frequency of the wave is minimum, that frequency is called fundamental frequency or fundamental vibration. Another one is overtone. Overtone means other than fundamental frequencies are called overtone. Other than fundamental frequency. Fundamental frequency is called overtone. Next one is harmonic. What is a harmonic? Harmonic means the integral multiple of fundamental frequency is called harmonic. Harmonic means the integral multiple of fundamental frequency is called harmonic. Another one is octave. So octave means the frequency double the fundamental is called octave. The frequency double the fundamental is called octave. So these are terms used in a stationary waves. What are the terms used in a stationary waves means? One is the fundamental vibrations or fundamental frequency. Another one is overtone. Third one is harmonic. What is the fundamental vibration means? The frequency of the wave is minimum. With the frequency of the wave is minimum, that frequency is called fundamental vibration or fundamental frequency. Again, what is the overtone? Other than fundamental frequency is called overtone. Other than fundamental frequency or more than fundamental frequencies, so resonance form means that is called overtone. Next one is harmonic. Harmonic means the integral multiple of fundamental frequency is called a harmonic. Another one is octave. Octave means with the frequency is double the fundamental frequency is called octave. Next one is mode of vibrations in a string. Suppose you consider a long wire. One end of the wire is attached to a fixed rigid support. Another end also attached or passed through from a pulley. you attach at certain weights means a tension form. When you pluck that one is here, one progressive waves is formed on another end, it will reflect back and come back to the origin position, that is the stationary waves. In this one, node and antinodes are formed. Now, mode of vibrations in a string. Consider L is a length of the string fixed between a two rigid support. When you pluck means here transverse stationary waves are formed. Transverse stationary waves are formed. So in this one, first one is fundamental frequency. What is the fundamental? Fundamental frequency or first harmonic. Fundamental frequency means, I already explained about what is the fundamental frequency. The minimum frequency of the waves is called fundamental frequency. So in this one, suppose you take a one long wave, when you pluck it means only, when you pluck this one, only one loop is formed. That frequency is called fundamental frequency. So in a fundamental frequency, at the rigid end, nodes are formed. At free end, antinodes are formed, or middle end, antinodes are formed. I already told the distance between two nodes is lambda by 2. The distance between two nodes is lambda by 2. Here, how many loops are formed? P is equal to only one loop. L is consider L is the length of the string. So L is equal to how much? Here we can write lambda by 2. Because here, how many nodes are formed? Two nodes are formed. And one antinode formed. Two nodes, one antinode formed. So here, how many number of loops are formed? Only one loop. P equal to 1, L equal to lambda by 2. Then we can write lambda equal to L. We know the relation between a frequency and velocity of the wave. V is equal to F lambda. The relation between velocity of the waves and frequency of the stationary waves, V equal to F lambda. In this one, F equal to frequency, F equal to V upon lambda. We know that velocity of the wave in a string, formula what? V equal to square root of T by mu. Mu is a linear mass density. T is a tension in a string. V is a velocity of the waves in a string. So we can write this one, F1 is equal to, F1, we'll let that one, F1 equal to, lambda value how much? 2L. So 1 by 2L, what is the formula of V? Square root of T by mu. This one is called fundamental frequency. Minimum frequency is formed. That frequency is called fundamental frequency. Second one is first overtone. First overtone or second harmonic. Second harmonic. In a first overtone, two loops are formed. First overtone, two loops are formed. At the rigid end, nodes are formed. So here antinode, here node, this one is a antinode. Here number of loops, P equal to number of loops equal to how many number of loops are formed? Two loops are formed. How many antinodes are formed? 1, 2. Two antinodes are formed. How many nodes are formed? 3 nodes are formed. Same like that one. We know that L is equal to how much? How many number of loops into lambda by 2? Like that also we can calculate. Or the distance between two nodes is lambda by 2. Again this one also a lambda by 2. That equal to 2 lambda by 2. So here L equal to, you can write 2 lambda upon 2. 2 lambda upon 2 is a length of the string. Next we can write V is equal to F lambda. F is equal to V by lambda. F is equal to V by lambda value how much? 2. In this one we can write lambda equal to 2L by 2. 2L by 2. We can write 2V by, so then we can write here, we can write F2 is equal to 2 by 2L square root of T by mu. V formula, square root of T by, this one is first overtone or second harmonic. Are you clear? So once again I am explain mode of vibration in nesting. This one is very important, 8 months for IP examination. So in this one, first one is you take a one long wire attached to a rigid support. Another end is pass through from only to a certain weight. When you pluck it means their loops are formed. That loops are single loops or sometimes double loops are formed, sometimes 3 loops. That is depend upon a distance between a rigid support and some factors are there. Pulling or the frequency or the tension in nesting also depend. So afterwards that one we will discuss. So now first one is fundamental frequency or first overtone form. So in this one, number of loops, one loop form, length L is considered, L is the length of the wire means L is equal to, so here in a fundamental frequency only one loop form. The distance between two nodes is lambda by 2, one antinode is formed. So here L equal to, we can write lambda by 2, lambda equal to 2L. We know the relation between velocity of the wave and frequency, V equal to F lambda. F is equal to V by lambda. We know the, what is the formula of velocity of the sound in air? Velocity of sound in nesting, V equal to square root of T by mu. Now F1 is equal to lambda value is 2L, 1 by 2L square root of T by mu. Similarly we can write first overtone or second harmonic. In a first overtone, second harmonic, 2 loops are formed. So number of loops 2. So here how many antinodes are formed? 2 antinodes and 3 nodes are formed. Always nodes are greater than antinodes. So here L equal to lambda by 2, the distance between the 2 nodes. Again distance between 2 nodes lambda by 2. We can write 2 lambda by 2, lambda equal to 2L by 2. We know that F equal to V equal to F lambda, F equal to V by lambda. F equal V means, here lambda means 2L by 2. So 2 by 2L we can write into V. V is square root of T by mu. Next one is third one. Third harmonic or second overtone. Third harmonic or second overtone. In the third harmonic, here 3 loops are formed. At the rigid end, nodes are formed. At the middle, antinode, node, antinode, node, antinode, nodes are formed. Here the distance between the 2 nodes is lambda by 2. Distance between the 2 nodes is lambda by 2. Distance between the 2 nodes is lambda by 2, like that. In this one, how many number of loops are formed? 3 loops are formed. 1, 2, 3. How many antinodes are formed? 1, 2, 3. 3 antinodes. How many nodes are formed? 1, 2, 3, 4. 4 nodes are formed. Total length L is equal to P into lambda by 2. P into lambda by 2. So P, how many loops are formed? 3 lambda by 2 we can write. That is a length equal to length of the string. Again, we know that V is equal to F lambda. In this one we can write lambda equal to 2L upon 3. Lambda equal to 2L upon 3. V equal to F lambda, then F3 equal to V upon lambda. So again we can write lambda value is 1 by 2L upon 3 V is square root of T by mu. F3 equal to, we can write 3 by 2L square root of T by mu. Like that. Okay, n sum. Suppose P loops are formed. Then what is the formula? Fp is equal to P by 2L. 1, 2, 3, 4, so on like that. P by 2L square root of T upon mu. Then what is the ratio fundamental? F1 is to, F2 is to, F3 equal to 1 is to 2 is to 3 ratio. This one is the mode of vibration in a string. After the class, you pause the video and make a neat notes. Otherwise, there is no use of the online classes.